Alright, we have a line, y equals ax plus b. So, not very helpful, right? We don't know the gradient, we don't know the y-intercept. But we do know that it is tangent to this quadratic at a certain point. Find the values of a and b. So essentially, this is a fancy way of saying, find the equation of the tangent to this function at that point, right? But then to conclude, we will say what a and b are. Alright, so to find the equation of a tangent line at a point, we first need to know the gradient at that point, because the gradient of the tangent line is the same as the gradient of the function at the point. Well, how do we work out the gradient of a function? Well, you guessed it. We work out the gradient function, right? Take the derivative. So the derivative of 2x squared is 4x. The derivative of minus 3x is minus 3. The derivative of plus 1 is 0. Cool, so we found our gradient function. Now, the gradient of the tangent is the same as the gradient of the function at 2, 3. So let's substitute in x equals 2 to find the gradient at x equals 2. So m for gradient is equal to 4 times 2 minus 3, 8 minus 3, which is 5. And actually m in this context is a. So we could just write, therefore, a equals 5. So what this means is, at the point 2, 3, if we were to draw this tangent line, the rise over the run, right, the gradient, will be equal to 5. So we're halfway there. Now, to find the y-intercept of the tangent, what we need to do is, so far we have y equals 5x plus b. You'll know from finding the equation of a straight line, if we have an x and a y value, in other words a point on the line, we can solve for the y-intercept. So, using 2, 3, right, the x and the y value, we can substitute into the equation and solve for b. So in for y goes 3, in for x goes 2 plus b. So 3 equals 10 plus b. Subtract 10 from both sides. So b equals minus 7. Right, so let's just conclude. Therefore, tangent line is y equals 5x minus 7 with a equaling 5 and b equaling minus 7. Awesome. So just to summarize this one, the question essentially was find the equation of the tangent line, but it just hid that with a and b, right? Finding the values of a and b instead. So the first step was to work out the gradient function, right? Taking the derivative. And if you did that and substituted in x equals 2 to find m, right, or a, that would be achieved for this question. If you went on to use that, substituted in the point and solved for b, that would be merit. And again, best practice just to write a concluding statement like we did.